Hello, my dear students. Welcome back to Shloka'S Academy YouTube channel. In the last video, we have started mole concept where we have discussed number of moles, how to calculate number of moles, what is Avogadro number, every basic term we have discussed. Now, today we are going to discuss how these mole concept can be used to do the numericals upon chemical equation. And what is limiting reagent, how limiting reagent will control the product formation, and what is excess reagent, and how we can determine the excess reagent by using given data, and what is percentage yield, and what is principle of atomic conservation and its application. All these things, very simple things and very, very important things. That we will discuss in a very easy way. Right. So in the last video, we have discussed how to calculate number of moles. If n is a number of moles, and if you know the weight of the given compound, given weight of the compound, if it is atom, if you take its gram atomic weight, weight by gram atomic weight, you will get number of moles. If it is molecule, you should take gram molecular weight so that you will get number of moles. This is first formula. And second formula, number of moles. When number of particles are given, means number of molecules or number of atoms have given number of particles, then if it is divided by Avogadro number. What is the value of Avogadro number? Which is equal to 6.023 into 10 to the power of 23. This is our second formula we have discussed. And third formula, when they have given volume of any gas at STP, volume of gas at STP in liters. Right. So then it should be divided by 22.4 liters to get number of moles. This is third formula. And fourth formula, if the volume, pressure, temperature are given at non-STP conditions, then according to ideal gas equation, you can use the formula, right, PV by RT, where R is the real gas constant, whose value is 0.0821 liter atmosphere per mole per Kelvin. That means whenever we use R value as this 0.0821, compulsory the volume should be in liters and pressure should be in atmosphere. Right. So to get very fast answers, so instead of 1 by 0.0821, instead of 0.0821, you can take 1 by 12. That gives us fast calculation. So these are the formulas that we have discussed in the last video. Now, today we are going to discuss calculations based on chemical equation, that is stoichiometry of the chemical reactions. We are going to discuss about stoichiometry of, right, chemical equations or chemical reactions. Chemical equations. So here chemical equations means it may be balanced or unbalanced. Both can be given in the question, right? Balanced, and it may be unbalanced also. Right. With balanced, we can know limiting reagent, and it can follow principle of atomic conservation, right? And law of mass of conservation and charge conservation. That means the reactants side and product side, they should have the same charge, same net charge. And if you take any reactant and product, there should be same number of atoms of each and every element on both sides. That is principle of atomic conservation. No atom is going to be destroyed. No atom is going to be created. Just old bonds are broken and new bonds are making. That is balanced equation. Unbalanced, no need to follow any of these conditions. So in these aspects, we are going to discuss what is limiting reagent, what is principle of atomic conservation, all these things. So first, before going to that, so how they can ask the question, I will explain with one example. Very simple example I am taking. Right. So these chemical equations may associated with in three ways. The first way is mole relation, means they can give the number of moles of reactants and they may ask the number of moles of products formed in the particular reaction. And the second one is mass relation. The given data may be given in terms of mass, and the question is about to find out the product or reactant in terms of mass only. And third one is volume relationship. Volume relationship. It may be at STP or other than STP conditions also. And all are interrelated with each other. And remember one thing, always number of moles are directly proportional to volume under identical conditions of temperature and pressure. For example, there are two reactants which are in 1:3 ratio, molar ratio. The volume ratio of those two reactants also 1:3 only under identical conditions. That is very important. Now let us see. So based on this, we have to find out, the question is like this, right? 2 moles of N2 and 6 moles of H2. 6 moles of H2 are reacting together according to this balanced equation. N2 plus 3H2 gives rise to 2NH3. This is a given data. They can ask the first question, calculate number of moles of NH3 formed in the above reaction. That is first question. Second question, they can ask, calculate the mass of NH3 formed in the above reaction. And third question, they can ask, calculate the volume of NH3 formed at a STP. And fourth question, they can ask, calculate the number of NH3 molecules formed in the above reaction. All four questions, the given data is purely in terms of moles, but here we have to find out moles of NH3 formed, mass of NH3 formed, volume of NH3 formed at STP, and number of NH3 molecules. Right. So it is very simple because here they have given the, what is that, balanced equation. When they given the balanced equation, what to do? Very simple. First, let me solve this question. I am taking N2 plus 3H2 gives rise to 2NH3. Right. What are the stoichiometric coefficients of reactants and products in this balanced equation? Stoichiometric coefficient. Nitrogen 1, that means 1 mole of nitrogen. And for hydrogen 3 moles of hydrogen. For ammonia 2 moles of ammonia. And what is the given data? Given data is in moles. So they have given 2 moles and it is 6 moles. And we have to find out this one. It is in terms of moles. In terms of moles. Now tell me, what should be? If it is 1 mole, 3, 1:3, it is also 1:3. So if it is 1 mole, it should be 2 moles. Now we have taken 2 moles. That should be 4 moles or not? What is the first question answer? 4 moles. What is the first question answer? 4 moles of ammonia is formed. 4 moles of NH3 is formed. Right. Second question, they are asking us about what is the weight of ammonia formed in the above reaction. From the formula number 1, that we have discussed in the last video, how to calculate the number of moles. Number of moles is equal to weight by gram molecular weight. Here we know the number of moles and we know the gram molecular weight. So we have to find out the weight of the substance. So by using this formula, what you can write, weight of ammonia formed is equal to number of moles of ammonia formed into gram molecular weight of ammonia, right? So weight of NH3 formed, what is the number of moles? 4, and its gram molecular weight is 28. You have got the second answer. And what is the third answer? We have to find out volume of NH3 at STP, which is equal to, again we can use the third formula here. Here I know the number of moles and I know this volume, and I want to find out volume of the NH3 at STP condition. I can use third formula. By using that one, what I can write, number of moles of ammonia into 22.4 liters. So here I have got the formula answer 4 into 22.4 liters. Now by using second formula, number of particles, number of NH3 molecules, I have to calculate, which is equal to number of moles into Avogadro number. This is how we can find out when the balanced equation is given. It is very simple. And one important thing, very, very important, you should remember that. So here, this is not stoichiometric coefficient, means always we will consider the balanced equation only. If you want to get stoichiometric coefficient, you have to consider the balanced equation only. And what about this 2, 6, that is given data? The 2, 6 is what? Given data. 2, 6 are given data, and this is we have to find out that we have got 4. Understood? So this is a case where we have the data in terms of moles. If the data is given in terms of weight, what we should do? Weight can be converted into moles by using the formula weight by molecular weight or not. We have to use that formula. Understood? So this is the first question. Now second question, where we need to discuss about limiting reagent. What is limiting reagent and how we can determine the limiting reagent? All these things we can discuss, which is very important concept, limiting reagent also. Right? Limiting reagent. So how can you represent the limiting reagent? How can you define the limiting reagent? Very simple, right? The reactant which consumed first, in the chemical reaction is called limiting reagent. That is limiting reagent. And always the quantity of product, it may be moles or, right, the quantity of the product can be determined by limiting reagent only. And how to find out limiting reagent? This is very important. How to find limiting reagent from the given data? Very simple. How to find limiting reagent? So first, for each reactant, the step 1, for each reactant, we have to calculate the value of X. What is X? X is equal to number of moles of reactant given by its stoichiometric coefficient. So this is step 1. For each reactant, we have to find out X. And after that, the reactant with small x will be the limiting reagent, and the reactant with large x value is excess reagent. Excess reagent always will left in the given at the end of the reaction. This is how we can find out the limiting reagent. Now let us see one example, then easily you can understand. So in this example, now I am taking mass relationship, right? So I am taking 56 grams of nitrogen and 6 grams of hydrogen are reacting, right, according to the balanced equation. N2 2NH3 gives rise to N2 plus 3H2 gives rise to the 2NH3. This is. Now, what are the questions? Means the first, find out limiting reagent. Second question, find out excess reagent. Third question, calculate number of moles of NH3 formed in the above reaction. And fourth question, weight of NH3 formed in the above reaction. And fifth question, volume of NH3 at STP formed in the above reaction. And sixth question, calculate the mass of excess reagent left behind at the end of the reaction. So these all 6 questions we can do in an easy way. The first thing what we have to do, they have given the balanced equation. Case 1, right? They have given balanced equation. What is a balanced equation? N2 3H2 gives rise to 2NH3. Now, first thing, we have to write stoichiometric coefficient 1, 3, and 2. We have to take given data in the moles, but we have weight, no? When you know the weight of the substance, how to find out its moles? Weight by molecular weight or not? So here what I can take, 56 by 28. Here 6 by 2. So number of moles, how many you will get? It is 2 moles, it is 3 moles. So I have got given data in terms of moles. Now I want to find out the limiting reagent. So for X value, I have to find out for this 2 by 1, for this 3 by 3. So I have got 2, I have got 1. So the reactant with small x value is a limiting reagent, and the reactant with large x value will be the excess reagent. Now, after finding the limiting reagent, you have to focus on limiting reagent only. According to the balanced equation, so who is limiting reagent? Hydrogen. And when you have 3 moles of the hydrogen, there is a formation of 2 moles of NH3. What is the relation? 3:2. Now, how many moles of limiting reagent you have? 1 mole. So if you have 3 moles of hydrogen, there is a formation of 2 moles of ammonia. When you have, when you have 3 moles, how many moles will be formed? Here we have 3 moles, no. Here we can expect 2 moles. So first question, limiting reagent is what? What is the answer for the first question? Limiting reagent is hydrogen. And what is the excess reagent? Nitrogen. And number of moles of ammonia formed? N2. Number of moles of ammonia formed? N2 or not? Why? Because according to this one, when you have 3 moles, there is a formation of 2 moles of ammonia. Now, according to the given data, how many moles of hydrogen you have? 3. So you will get again 2 moles. If there are 6 moles, you will get 4 moles. If there are only 1.5 mole of H2, you will get 1 mole. If there are 1 mole, you will get 2 by 3 moles of NH3. I hope you understand how to find it. Now, what is the weight of NH3? 2 into 17. What is the volume of NH3? 2 into 22.4 liters. What is the mass of excess reagent that left behind? This is very important. So at time t is equal 0, what do we have? We have 2 moles of N2 and 3 moles of H2. Out of 2 moles, how many moles you have reacted? 1 mole. And it is all 3 moles get reacted because limiting reagent will be consumed totally. So what is the number of moles of reactant at the end of the reaction? We have 1 mole, 0 mole, and 2 moles. So the weight of excess reagent left behind is 1 mole of N2. That means 28 grams as left. So this is how we can do the questions on limiting reagent, right? And what is principle of atomic conservation and how we can use principle of atomic conservation in case of these chemical reactions. That is very important. Now, here I am taking one question, right? Same third question, right? So here they are taking that, So what I'm taking, 14 grams of N2, right? And 6 grams or 10 grams of H2 are reacting to form NH3. That's it. Nothing is given. 14 grams of N2, not this one, 3 grams of H2. 3 grams of H2 are reacting to form NH3. Now, first question, calculate the amount of NH3 formed. And second question, calculate the volume of NH3 at STP. And number of moles also, you can do it. So now what to do here? They haven't provided us a balanced chemical equation. Now we have to apply the principle of atomic conservation. Is very useful when there is no balanced equation. Right, there is no balanced equation, but they have provided reactants N2 and H2. What is a product? NH3. So from this I can write an unbalanced equation. N2H2 gives rise to NH3. It is totally unbalanced equation. Even no need to balance it. Now, according to Poac, principle of atomic conservation, what is that? Number of moles of atoms of a particular element at reactant side must be equal to the number of moles of atoms of a particular element at product side. RHS must be equal to the LHS. That is principle of atomic conservation. Now let us apply this principle of atomic conservation with respect to nitrogen. I am applying Poac with respect to nitrogen. Right, surely we have to take atoms only. Now tell me, in unbalanced equation, so where do you find nitrogen? the nitrogen is in N2 or not? In 1 mole of N2, how many nitrogen atoms are there? 2 or not? Atomicity, 2 into number of moles of nitrogen. And we don't have nitrogen anywhere at reactant side, only in N2. And where do you find nitrogen in the product side? Ammonia. In 1 mole of ammonia, how many nitrogen atoms are there? 1. So 1 into number of moles of NH3. This is first. Now tell me, 2 into number of moles of nitrogen. How can you find out? By weight by molecular weight. 14 by 28 equal to 1 into number of moles of NH3. I don't know what it is. Let it be X. Right. So from this, what you can write? 2 1s are 2, 14s are, and 14s are 1. So number of moles of ammonia formed is 1. I have got the answer. Otherwise, you take with respect to hydrogen. Here we have got the answer. Even you can take with respect to hydrogen also. Right. So what is that? 2 into number of moles of H2 equal to 3 into number of moles of NH3 or not? 3 into number of moles of NH3. Right. What they have given? 2 into, right, number of moles, weight by molecular weight. 2 into 3 by 2, which is equal to 3 into number of moles of NH3. What do you get? Again, you will get 1 or not? I mean, same answer we have got. This is how we can find out when they given unbalanced equation. Unbalanced equation. This is how we can apply POAC. Understood? So this is about POAC. Next, what is percentage yield? What is percentage yield? How to find out percentage yield? And the formula we will discuss. Percentage yield. Yield means with respect to product, not at all reactant. So for example, here I am taking N2 plus 3H2 gives rise to 2NH3. 1 mole, 3 mole, and 2 mole. Stoichiometry coefficient. And the given data, what they have given? 2 moles, 6 moles. Then how much you will expect? Obviously, 4 moles or not. 4 moles is expected, but it is forming only 3 moles. What is the expected amount? 4 moles or not? In this case, the percentage of yield is not 100%. 3 by 4 means 3 is what? Given or not? Given amount of product. Given amount of product by, right, actual or calculated amount of product. Calculated amount of product into 100. So what is that? 3 into amount means in grams we have to take 3 into 17 by 4 into 17 into 100. So what is the percentage of yield in this case? 75% or not? This is how we can find out percentage yield. So this is very simple relation for mole, mass, and volume, and interrelation between them. Right. In the next video, we can do more questions on this concept. Please share, like, comment, and subscribe my channel, Shloka'S Academy YouTube channel. Very soon, I am going to launch app, Shloka'S Academy app, where you can get more DPPs, more tests, and more material, all these things. Thank you.